After sending over 650 humans into space over the course of more than 50 years and under a variety of situations, we've discovered a constant pattern required for sustaining human life and functionality, even during our most extended and difficult missions. One of the important results is the need of eating regularly, numerous times per day. You may question, how do we manage this during extended stays on the moon? It presents a substantial barrier, given the costly expenditures connected with bringing food from Earth, including rocket launches and sustaining supply over extended durations. However, growing food on site could dramatically increase human survivability in even the most hostile circumstances. A new study suggests that producing chickpeas on the moon may be possible. Join me in this video to learn how we can accomplish this incredible feat. Motivations. In the goal of understanding how astronauts could sustainably inhabit the moon, continuing studies and research look into a variety of topics, including the critical concern of food production. After all, it is unrealistic to rely on food delivery similar to those on Earth. Instead, we're looking into the viability of growing food directly on the lunar surface. This is consistent with our broader goal of creating a permanent base at the moon's south pole. Enter chickpeas. Yes, you heard that right, chickpeas. Not your typical topic of discussion, but these hardy legumes are at the vanguard of lunar agriculture research. Jessica Atkin and Sarah Oliveira Santos made a surprising scientific discovery by publishing a landmark paper proving the ability to grow chickpeas in lunar regolith. Now you might be wondering how this is feasible. And more significantly, will astronauts be able to prepare hummus on the moon? Growing chickpeas on the moon. To understand this, we must first discuss what is known as regolith. Imagine it as the moon's form of Earth, but not precisely like the dirt in your backyard. See, regolith is made up of small rock and dust particles that blanket the moon's surface. But here's the kicker. It's missing something vital, a nutrition. You know those beneficial substances that make plants grow large and strong? Regolith doesn't have them. It's like attempting to grow plants in a sandbox with no fertilizer. Why is this such a big deal? When it comes to producing plants, whether on Earth or on the moon, we need nutrient-rich soil to help them grow healthy and tasty. However, because there are no plants or living things on the moon, its soil known as regolith is quite barren. It has been battered by space rocks for billions of years, as well as blasted by radiation from the sun and other cosmic stuff. As you can expect, it's not the most comfortable environment for plants to grow in. Now here's when things become complicated. We can't simply scoop up a bunch of moon dirt and bring it back to Earth to experiment with. No, that is not how it works. Instead, scientists create something called simulated soil. It's like creating a simulated version of the moon's soil right here on Earth. They blend substances to closely resemble the things found on the moon's surface. That way they can conduct tests and grow plants in soil that is similar to what they would find up there. But in order to recreate regolith, we need to understand its chemical composition. During previous lunar missions, we recovered a considerable amount of material from the moon, including regolith in the form of fine dust and bigger rocks. We discovered that they are made of microscopic crystals that are oxides of various metals and are often glassy, making it an unsuitable environment for growing plants or supporting life. In fact, breathing this regolith poses a risk to the astronauts themselves. If it's in little doses, it's not a big deal for astronauts who go to the moon for 2 or 3 days, but if they have to stay for months, it can be a serious problem. For example, regolith particles are abrasive and can irritate the respiratory tract, resulting in coughing, wheezing, and difficulty breathing. Extended exposure may cause respiratory infections or exacerbate pre-existing respiratory disorders. Essentially, while producing plants in regolith may be doable, consuming the produce and inhaling the air could endanger our health, particularly our respiratory systems. So is there a solution to this conundrum? In their paper, the two researchers propose a solution based on worms and fungi. While it may appear unorthodox, this strategy shows promise. Fungi and worms could become crucial friends for long-term lunar and Martian missions, helping to create sustainable habitats for human habitation. Fungi. The premise in the study is not entirely novel. It is based on things we already do on Earth. But what's exciting is that they're doing it for the first time on the moon. They're using techniques we use to improve poor soil for growing things. One of the techniques they're experimenting with is employing compost worms and arbuscular mycorrhizal fungus, AMF. Let's look at how this works, specifically how AMF can assist eliminate toxic material in the soil and help plants grow better in harsh situations. AMF works with plant roots to help plants absorb more nutrients from the soil. This allows the plants to grow larger and healthier. Plants cannot move to get sustenance. Instead, they rely on the soil surrounding their roots. However, when they collaborate with AMF, they gain access to additional nutrients because AMF sends out tiny threads that penetrate deeper into the soil, bringing back more nutrients for the plants. This makes the plants stronger and allows them to grow more. Furthermore, when there is insufficient water in the soil, AMF assists plants by locating water in areas where plant roots cannot reach. So even in dry spells, plants with AMF companions can acquire enough water to survive. In places like the moon where the soil is poor and there is little water, having plants with AMF pals could be a game changer. It might mean astronauts have a better chance of cultivating their own food and keeping healthy during long-term space missions. Worms. So this is the role that fungi play. So what about the worms? Why are they so important? Worms, dubbed the intestines of the world by Aristotle, play an important role in soil fertility and plant growth. These creatures have a hydrostatic skeleton which allows them to move by contracting and relaxing their bodies. Their respiration and gas exchange are likewise dependent on this skeleton, as long as their skin remains moist. Worms are hermaphrodites, which means they generate both male and female gametes, but cannot fertilize themselves. Instead, they practice cross-fertilization, which means that after mating, both individuals can create offspring. The eggs hatch into whitish babies inside a capsule called an ootheca, and they reach sexual maturity within a few weeks. The worms utilized in vermicomposting are epigeic, which means they live in the top 10 to 15 centimeters of the soil. The tiger worm and the red worm are two often used species. These worms prefer temperatures between 15 and 20 degrees Celsius, but can tolerate temperatures ranging from 4 degrees Celsius to 30 degrees Celsius. They are important for soil fertility because they naturally plow the soil by burrowing tunnels and devouring organic wastes, which promotes their degradation into simpler compounds. Worms defecate digested material in the form of casts, which are then transformed into humus by enzymatic action of diverse soil microbes. This is spelled with only one M and has nothing to do with chickpeas. It is a nutrient-rich soil that, unlike other chemical or organic fertilizers, is readily available to plants due to its low carbon-to-nitrogen ratio, which makes nitrogen easily accessible. Furthermore, humus has a physical structure with numerous macro and micropores, which promotes soil aeration, drainage, and water retention capacity. So we've explained how worms and fungi can help improve our soil. But how about the experiment? Let's see how the experiment was carried out. Experiment and results. The researchers planted chickpea seeds that had been chosen for their compact size and capacity to endure stress. Chickpeas are a great protein source that need less water and nitrogen than other crops. To suit space limits in the habitat, the scientists chose a Desi chickpea variety. The pots were housed in a temperature-controlled grow tent for 4 months, and the researchers hydrated the soil on a regular basis with filtered water. By day 13, all seeds had germinated, but the resulting plants showed indicators of stress, such as chlorophyll shortage, dwarfism, reduced leaf area, and limited shoot branching. The current study suggests that these symptoms may be caused by the soil's insufficient water retention ability. Chickpeas took 120 days to mature in the experiment, compared to 100 days on Earth. The harvested chickpeas will be tested for heavy metal content, with further study underway on this front. Despite these hurdles, researchers believe that these preliminary results could pave the way for plant cultivation on the moon. After all, this study represents the first successful attempt to grow chickpeas in lunar soil, although in a simulated environment. Anyway, this is hardly the first experiment involving plant growth on the moon. For example, did you know that in May 2022, scientists at the University of Florida claimed that they had successfully produced plants from seeds put in lunar samples? NASA astronauts gathered this lunar surface material decades ago during the Apollo mission. This accomplishment puts us closer to understanding the feasibility of growing plants on the moon for future exploration. As we conclude up our video, consider why growing plants on the moon would be a good idea. It's extremely critical for future space missions. First and foremost, it allows us to continue operating without relying too heavily on Earth. Growing food there eliminates the need to send it from our planet, which can be difficult and costly. Furthermore, having fresh vegetables can help astronauts stay fit and happy during their travels. It's also beneficial for their mental health to have something green nearby. Plants also help to produce oxygen, which is necessary for breathing, and they absorb carbon dioxide, making the air healthier to breathe. Growing plants on the moon is thus a significant step toward a more comfortable and long-term existence in space. Who knows, maybe one day our grandchildren may like moon hummus as their favorite food. Alright folks, this is the end of the video. Thanks for watching. What should we cover next? Feel free to leave your opinions in the comments section below, and stay tuned for our next video.